See how to solve this problem. Shortest pathing directed acyclic graph. Okay, so the question is you will be given a directed acyclic graph and you will be given a source. Then you need to find the shortest path from source to all other vertices. If there is no path possible, the distance is -1. Okay, let's see how can we solve this problem. Let's see this with an example. So let's see this example. And the prerequisites for this problem is you should know topological sort. Okay, so I'll be using uh, topological sort using DFS. Okay, I'm assuming you know this. Okay, so if you perform topological sort using DFS, you use a stack. There you store elements in an order. Okay, like, what will be the order we will get? We'll have three. It is a reverse. Okay, reverse of the final order. So what will it be? 3, somewhere maybe 1, 2, 4, 0, 5, 6. Okay, so this is my front element. 6 is my front element here. By front I mean this is the top element in this tag. This is the top is here. 6, 5, 0, next 4, next 2, next 6, next 1, next 3. Okay, yeah. We'll have this if we use DFS. What I'm going to do after this is till here you should know. So after this, step. What are the steps? Uh, I'll pop each element from stack. Okay. I'll pop each element from stack. This one. Just a second. Next. So what do we need before this? I'll mention. So you need a visited array to mark nodes. So we have 7 nodes. So initially all of them are not visited. 0, 0, 0, 0, 0, 6 and 7. Okay. None of them are visited and a distance array to store the distance. Initially I'll keep them all of them to max, any max integer, something like mx max number. Okay, so we need a source right now. Our source is 0, so I'll mark this as 0 since distance from 0 to 0 is 0. Okay, now let's proceed. So next what I'm going to do is I'll pop each element from stack and I'll check its neighbors. I'll relax edges from that vertex. Okay, I'll show you what do I mean by relaxing it. Okay, so what is the first one? First I'll pop 6. Okay, so 6 is the current element. I'll remove 6 and I'll see its neighbors. What are the neighbors of 6? 0 and 5. Okay, I'll calculate distance from 6 to 0. What is the distance till 6? It is max, and 6 to 0 2, so it will be max plus 2. Okay, is 0 greater? So currently I'm getting max plus 2 and I already have 0, which is minimum. 0 is minimum, so I don't change it. Okay, so 0 is done. Next I'll check for 5. So for 5, um, so till 6 it is max, and 6 to 5 it is 3, max plus 3, and 5 has already max, so which is minimum? Max is minimum, so I'll keep it same. Okay, 6 is done. Now I'll pop 5 and I'll see for 5. So 5 neighbors are 0 till here. It is max, max plus 1, it is 0, max plus 1, 0 is minimum. I'll keep it same. Now let's see. I'll pop 0. Okay, um, I check what are its neighbors. 4 and 2 till 0. The distance is 0. Okay, 0 to 4 it's 3. Okay, at 4 I have distance is max. I got 3. This is minimum, so I'll update this. So 3 is a new distance for here. Okay, next I'll check for 2. Similarly, 0 to 2 it is 1. 0 1, this is 1, this is max, which is minimum 1. So I'll update for 2 also, which is distance is 1. Okay, 0 is done. Next I'll check for 4. Okay, so what are the neighbors of 4? It is 1. Till 4 it is 3, and 4 to 1 it is 2, and at 1 I have max. This is 5, max. 5 is minimum. I'll update this. Okay, what are other neighbors? Only 1 is the neighbor. This is done. Okay, 4 is done. Next I'll check for 2. What are the neighbors of 2? It is 3. Okay, now till 2 it is 1, and 2 to 3 it is 3, and I have max, so this is less than, so I'll update it to 4. Okay, so 2 is also done. Now let's check for 1. Till 1 it is 5. Okay, till 1 it is 5. And what are the neighbors? Neighbors are 3, which is 5 plus 1, 1 to 3, and I have distance to 3 is 4 already, so 6 is not less than, 6 is greater than 4, so I won't update it. Now I'll pop 3 and I'll check its neighbors. Neighbors of 3 are nothing, so I have got my distances, and whatever that are remaining as max, that means you cannot reach them. Change them to -1. Okay, so now you got your answer. Okay, so this is how we'll be solved it. Let's see how can we write code for this. So I'll be directly explaining the code. As I said, you should know topos before. So I'll do topos using DFS, and I'll store those what is it? Nodes in the reverse order in the stack, and I'll pop each of them. After while popping each of them, I'll check its neighbors, and I'll check the distance to current and current to neighbor. If it is less than the neighbor distance, I'll update the neighbor distance. So I will do this for all the nodes. At the end, if any node has distance as maximum value, I'll update it to -1. Okay, and I'll return the distance. Okay, that's how it will be solved. Yeah, thank you. Okay, sorry, I forgot to explain the time and space complexity. Let's see that. Since we are using topological set, most of it is same. So which is since it is directed, what do I do? This is a big of V. This is big of E. I'll write it here. Big of V plus big of E, number of edges, this one, and this is at max. I will iterate all the edges, which is again big of E. Okay, so space would be a stack which is big of V, visited big of V, and distance big of V, and the recursive stack space that is big of V. So this is the time and space complexity. Thank you.